Disclaimer: the information on this course is intended to be for reference and general information only. It does not purport to be comprehensive nor to provide other professional advice. CPD Institute does not warrant or represent that such information is complete, accurate or up to date. Further, no warranty regarding non-infringement, security, fitness for purpose or freedom from computer viruses is given in connection with such information and any other websites linked to or accessed via this online course. CPD Institute accepts no liability for any loss or damage however arising from any use or access of this online course or any reliance upon any content of this online course. Furthermore, this online course may contain reference to certain articles, magazines or books for educational or demonstration purposes. Any intellectual property right in such materials may reside in that third party. If you have any questions related to copyright, please contact us. If there is any inconsistency or ambiguity between the English version and any other version, the English version shall prevail. The disclaimer is posted in all of our websites, such as www.visacpd.com and www.allcpd.com. By registering this course, you understand and agree with our disclaimer. Again, the information provided in the seminars is general and not specific in nature. While it is our sincere effort to provide our clients with the most up-to-date accurate information, however we do not assume any responsibility for any damage, harm, injury, penalty, loss or cost that may be consequently acquired or sustained upon using the information generically provided by our expert. Rather we encourages you to keep abreast with the federal, provincial, municipal and other applicable codes and bylaws and apply them in your practice appropriately. We may refer to specifications or quote codes in examples or as answers to specific questions asked during the seminars by attendees, but these should not be taken in verbatim and not be applied to your project generically. Research, inquire or consult with relevant consultants, advisors and municipal officials before undertaking any construction project or making any construction-related decisions. As each construction project is unique, relevant decisions should be made after analyzing and interpreting all pertinent information. We assume no direct or indirect influence in the decision-making process regarding any design or construction project. Follow the manufacturer's instructions and keep in touch with the ever-changing products. CPD Institute does not assume responsibility for use of incorrect product or using products incorrectly. Thank you for your attention. Please turn off your cell phone, pay attention to the training, as you will be required to pass quizzes at the end of each module.
Hello everyone. Please allow me to introduce you to this course. This course develops a specific viewpoint in discussing the participants, the processes, and the techniques of project management for construction. This viewpoint is that of owners who desire completion of projects in a timely, cost-effective fashion. Profound implications for the objectives and methods of project management result from this perspective. The life cycle of costs and benefits from initial planning through operation and disposal of the facility are relevant to decision-making. An owner is concerned with the project from the cradle to the grave. Construction costs represent only one portion of the overall life cycle costs. Optimizing performance at one stage of the process may not be beneficial overall if additional costs or delays occur elsewhere. For example, saving money on the design process would be a false economy if the result is excess construction costs. Fragmentation of project management among different specialists may be necessary, but good communication and coordination among the participants is essential to accomplish the overall goals of the project. New information technologies can be instrumental in this process, especially the Internet and specialized extranets. Productivity improvements are always of importance and value. As a result, introducing new materials and automated construction processes is always desirable as long as they are less expensive and are consistent with desired performance. Quality of work and performance are critically important to the success of a project, since it is the owner who will have to live with the results. In essence, adopting the viewpoint of the owner focuses attention on the cost-effectiveness of facility construction rather than competitive provision of services by the various participants. While this course is devoted to a particular viewpoint with respect to project management for construction, it is not solely intended for owners and their direct representatives. By understanding the entire process, all participants can respond more effectively to the owner's need in their own work, in marketing their services, and in communicating with other participants. In addition, the specific techniques and tools discussed in this course, such as economic evaluation, scheduling, management information systems, etc., can be readily applied to any portion of the process. As a result of the focus on the effective management of entire projects, a number of novel organizational approaches and techniques become of interest. First and foremost is the incentive to replace confrontational and adversarial relationships with the spirit of joint endeavor, partnership, and accomplishment. For example, we discuss the appropriate means to evaluate risks and appropriate participants to assume the unavoidable risks associated with constructed facilities. Scheduling, communication of data, and quality assurance have particular significance from the viewpoint of an owner, but not necessarily for individual participants. The use of computer-based technology and automation also provides opportunities for increased productivity in the process. Presenting such modern management options in a unified fashion is a major objective of this course. The unified viewpoint of the entire process of project management in this course differs from nearly all other courses on the subject. Most courses in the area treat special problems, such as cost estimating, from the viewpoint of particular participants, such as construction managers or contractors. This curriculum reflects the fragmentation of the construction process among different organizations and professionals. Even within a single profession, such as civil engineering, there are quite distinct groups of specialists in planning, design, management, construction, and other subspecialties. Fragmentation of interest and attention also exists in nearly all professional programs and educational programs. While specialty knowledge may be essential to accomplish particular tasks, participants in the process should also understand the context and role of their special tasks. This course is intended primarily as a course for advanced undergraduates, beginning graduate students, or professionals continuing their education in engineering, construction, architecture, or facilities management. Examples and discussion are chosen to remind students that project management is a challenging, dynamic, and exciting enterprise and not just a record of past practices. It should also be useful for professionals who wish an up-to-date reference on project management. Like the 5 blind men encountering different parts of an elephant, each of the numerous participants in a process of planning, designing, financing, constructing, and operating physical facilities has a different perspective on project management for construction. Specialized knowledge can be very beneficial, particularly in large and complicated projects, since experts in various specialties can provide valuable services. However, it is advantageous to understand how the different parts of the process fit together. Waste, excessive cost, and delays can result from poor coordination and communication amongst specialists. It is particularly in the interest of owners to ensure that such problems do not occur, and it behooves all participants in the process to heed the interests of owners because in the end, it is the owners who provide the resources and call the shots. By adopting the viewpoint of the owners, we can focus our attention on the complete process of project management for constructed facilities rather than the historical roles of various specialists such as planners, architects, engineering designers, constructors, fabricators, material suppliers, financial analysts, and others. To be sure, each specialty has made important advances in developing new techniques and tools for efficient implementation of construction projects. However, it is through the understanding of the entire process of project management that these specialists can respond more effectively to the owner's desires for their services in marketing their specialties and improving the productivity and quality of their work. The introduction of innovative and more effective project management for construction is not an academic exercise. As reported by the Construction Industry Cost Effectiveness Project of the Business Roundtable, by common consensus and every available measure, the United States no longer gets its economy's worth in construction, the nation's largest industry. The creeping erosion of construction efficiency and productivity is bad news for the entire U.S. economy. Construction is a particularly seminal industry. The price of every factory, office building, hotel, or power plant that is built affects the price and must be charged for the goods or services produced in it or by it. And that effect generally persists for decades. Too much of the industry remains tethered to the past, partly by inertia and partly by historic divisions. Improvement of project management not only can aid the construction industry, but may also be the engine for the national and world economy. However, if we are to make meaningful improvements, we must first understand the construction industry, its operating environment, and the institutional constraints affecting its activities, as well as the nature of project management. Let's begin our first topic, the project lifecycle. The acquisition of a constructed facility usually represents a major capital investment, whether its owner happens to be an individual, a private corporation, or a public agency. Since the commitment of resources for such an investment is motivated by market demands or perceived needs, the facility is expected to satisfy certain objectives within the constraints specified by the owner and relevant regulations. With the exception of the speculative housing market, where the residential units may be sold as built by the real estate developer, most constructed facilities are custom-made in consultation with the owners. A real estate developer may be regarded as a sponsor of building projects as much as a government agency may be the sponsor of a public project and turns it over to another government unit upon its completion. From the point of view of project management, the terms owner and sponsor are synonymous because both have the ultimate authority to make all important decisions. Since the owner is essentially acquiring a facility on a promise in some form of agreement, it will be wise for any owner to have a clear understanding of the acquisition process in order to maintain firm control of the quality, timeliness, and cost of the completed facility. Essentially, a project is conceived to meet market demands or needs in a timely fashion. Various possibilities may be considered in the conceptual planning stage, and the technological and economic feasibility of each alternative will be assessed and compared in order to select the best possible project. The financing schemes for the proposed alternatives must also be examined, and the project will be programmed with respect to the timing for its completion and for available cash flows. After the scope of the project is clearly defined, detailed engineering design will provide the blueprint for construction, and the definitive cost estimate will serve as the baseline for cost control. In the procurement and construction stage, the delivery of materials and the erection of the project on site must be carefully planned and controlled. After the construction is completed, there is usually a brief period of startup or shakedown of the constructed facility when it is first occupied. Finally, the management of the facility is turned over to the owner for full occupancy until the facility lives out its useful life and is designated for demolition or conversion. Furthermore, an owner may have in-house capacities to handle the work in every stage of the entire process, or may seek professional advice and services for the work in all stages. Understandably, most owners choose to handle some of the work in-house and to contract outside professional services for other components of the work as needed. By examining the project lifecycle from the owner's perspective, we can focus on the proper roles of various activities and participants in all stages, regardless of the contractual agreements for different types of work. In the United States, for example, the U.S. Army Corps of Engineers has in-house capabilities to deal with planning, budgeting, design, construction, and operation of waterway and flood control structures. Other public agencies, such as state transportation departments, are also deeply involved in all phases of a construction project. In the private sector, many large firms such as DuPont, Exxon, and IBM are adequately staffed to carry out most activities for plant expansion. All these owners, both public and private, use outside agents to a greater or less degree when it becomes more advantageous to do so. The project lifecycle may be viewed as a process through which a project is implemented from cradle to grave. This process is often very complex. However, it can be decomposed into several stages. The solutions at various stages are then integrated to obtain the final outcome. Although each stage requires different expertise, it usually includes both technical and managerial activities in a knowledge domain of the specialist. The owner may choose to decompose the entire process into more or less stages based on the size and nature of the project, and thus obtain the most efficient result in implementation. Very often, the owner retains direct control of work in the planning and programming stages, but increasingly outside planners and financial experts are used as consultants because of the complexities of the projects. Since operation and maintenance of a facility will go on long after the completion and acceptance of a project, it is usually treated as a separate problem, except in the consideration of the life cycle cost of the facility. All stages from conceptual planning and feasibility studies to the acceptance of a facility for occupancy may be broadly lumped together and referred to as the design or construct process, while the procurement and construction alone are traditionally regarded as a province of the construction industry. Owners must recognize that there is no single best approach in organizing project management throughout a project's lifecycle. All organizational approaches have advantages and disadvantages, depending on the knowledge of the owner in construction management, as well as the type, size, and location of the project. It is important for the owner to be aware of the approach which is most appropriate and beneficial for a particular project. In making choices, owners must be concerned with the life cycle costs of constructed facilities rather than simply the initial construction costs. Saving small amounts of money during construction may not be worthwhile if the result is much larger operating costs or not meeting the functional requirements for the new facility satisfactorily. Thus, owners must be very concerned with the quality of the finished product as well as the cost of the construction itself. Since facility operation and maintenance is a part of the project lifecycle, the owner's expectation to satisfy investment and objectives during the project lifecycle will require consideration of the cost of operation and maintenance. Therefore, the facility's operating management should also be considered as early as possible, just as the construction process should be kept in mind at the early stages of planning and programming. Let's continue. The next topic we're talking about is major types of construction. Since most owners are generally interested in acquiring only a specific type of constructed facility, they should be aware of the common industrial practices for the type of construction pertinent to them. Likewise, constructed industry is a conglomeration of quite diverse segments and products. Some owners may procure a constructed facility only once in a long while and tend to look for short-term advantages. However, many owners require periodic acquisition of new facilities and/or rehabilitation of existing facilities. It is to their advantage to keep the construction industry healthy and productive. Collectively, the owners have more power to influence the construction industry than they realize because, by their individual actions, they can provide incentives or disincentives for innovation, efficiency, and quality in construction. It is to the interest of all parties that the owners take an active interest in construction and exercise beneficial influence on the performance of the industry. In planning for various types of construction, the methods of procuring professional services, awarding construction contracts, and financing the constructed facility can be quite different. For the purpose of discussion, the broad spectrum of constructed facilities may be classified into four major categories:
each with its own characteristics. Now on to our next topic, residential housing construction. Residential housing construction includes single-family houses, multifamily dwellings, and high-rise apartments. During the development and construction of such projects, the developers or sponsors who are familiar with the construction industry usually serve as surrogate owners and take charge, making necessary contractual agreements for design and construction, and arranging the financing and sale of the completed structures. Residential housing designs are usually performed by architects and engineers, and the construction executed by builders who hire subcontractors for the structural, mechanical, electrical, and other specialty work. An exception to this pattern is for single-family houses, which may be designed by builders as well. The residential housing market is heavily affected by general economic conditions, tax laws, and the monetary and fiscal policies of the government. Often, a slight increase in total demand will cause a substantial investment in construction, since many housing projects can be started at different locations by different individuals and developers at the same time. Because of the relative ease of entry, at least at the lower end of the market, many new builders are attracted to the residential housing construction. Hence, this market is highly competitive, with potentially high risks as well as high rewards. Now for our last topic in the chapter, institutional and commercial building construction. Institutional and commercial building construction encompasses a great variety of project types and sizes, such as schools and universities, medical clinics and hospitals, recreational facilities and sports stadiums, retail chain stores and large shopping centers, warehouses and light manufacturing plants, and last but not least, skyscrapers for offices and hotels. The owners of such buildings may or may not be familiar with construction industry practices, but they usually are able to select competent professional consultants and arrange the financing of the constructed facilities themselves. Specialty architects and engineers are often engaged for designing a specific type of buildings, while builders or general contractors undertaking such projects may also be specialized in only that type of building. Because of the higher cost and greater sophistication of institutional and commercial buildings in comparison with residential housing, this market segment is shared by fewer competitors. Since construction of some of these buildings is a long process which, once started, will take some time to proceed until completion, the demand is less sensitive to general economic conditions than that for speculative housing.
Hello everyone, please allow me to introduce you to this course. Welcome to Chapter 2. In the first topic, we will give you an introduction to specialized industrial construction. Specialized industrial construction usually involves very large-scale projects with a high degree of technological complexity, such as oil refineries, steel mills, chemical processing plants, and coal-fired or nuclear power plants. The owners usually are deeply involved in the development of a project and prefer to work with designers, builders, such that the total time for the completion of the project can be shortened. They also want to pick a team of designers and builders with whom the owners have developed good working relations over the years. Although the initiation of such projects is also affected by the state of the economy, long-range demand forecasting is the most important factor since such projects are capital-intensive and require a considerable amount of planning and construction time. Governmental regulation, such as the rulings of the Environmental Protection Agency and the Nuclear Regulatory Commission in the United States, can also profoundly influence decisions on these projects. A similar area is infrastructure and heavy construction. Infrastructure and heavy construction includes projects such as highways, mass transit systems, tunnels, bridges, pipelines, drainage systems, and sewage treatment plants. Most of these projects are publicly owned and therefore financed either through bonds or taxes. This category of construction is characterized by a high degree of mechanization, which has gradually replaced some labor-intensive operations. Now that we've talked about a couple types of large-scale constructions, let's move on briefly to the selection of professional services. When an owner decides to seek professional services for the design and construction of a facility, he or she is confronted with a broad variety of choices. The type of services selected depends to a large degree on the type of construction and the experience of the owner in dealing with various professionals in the previous projects undertaken by the firm. Generally, several common types of professional services may be engaged either separately or in some combination by the owners. At the early stage of strategic planning for a capital project, an owner often seeks the services of financial planning consultants, such as certified public accounting firms, to evaluate the economic and financial feasibility of the constructed facility. Particularly with respect to various provisions of federal, state, and local tax laws which may affect the investment decision. Investment banks may also be consulted on various options for financing the facility in order to analyze their long-term effects on the financial health of the owner organization. Traditionally, the owner engages an architectural and engineering firm, also known as an A&E firm, or a consortium as technical consultant in developing a preliminary design. After the engineering design and financing arrangements for the project are completed, the owner will enter into a construction contract with a general contractor, either through competitive bidding or negotiation. The general contractor will act as a constructor and/or a coordinator of a large number of subcontractors who perform various specialties for the completion of the project. The A&E firm completes the design and may also provide on-site quality inspection during construction. Thus, the A&E firm acts as a prime professional on behalf of the owner and supervises the construction to ensure satisfactory results. This practice is most common in building construction. In the past 2 decades, this traditional approach has become less popular for a number of reasons, particularly for large-scale projects. The A&E firms, which are engaged by the owner as the prime professionals for design and inspection, have become more isolated from the construction process. This has occurred because of pressure to reduce fees to A&E firms, the threat of litigation regarding construction defects, and lack of knowledge of new construction techniques on the part of architect and engineering professionals. Instead of preparing a construction plan along with the design, many A&E firms are no longer responsible for the details of construction, nor do they provide periodic field inspections in many cases. As a matter of fact, such firms will place a prominent disclaimer of responsibilities on any shop drawings they may check, and they will often regard their representatives in the field as observers instead of inspectors. Thus, the A&E firm and the general contractor on a project often become antagonists who are looking after their own competing interests. As a result, even the constructability of some engineering designs may become an issue of contention. To carry this protective attitude to the extreme, the specifications prepared by an A&E firm for the general contractor often protects the interests of the A&E firm at the expense of the interests of the owner and the contractor. In order to reduce the cost of construction, some owners introduce value engineering, which seeks to reduce the cost of construction by soliciting a second design that might cost less than the original design produced by the A&E firm. In practice, the second design is submitted by the contractor after receiving a construction contract at a stipulated sum, and the saving in cost resulting from the redesign is shared by the contractor and the owner. The contractor is able to absorb the cost of redesign from the profit in construction or to reduce the construction costs as a result of the redesign. If the owner had been willing to pay a higher fee to the A&E firm or to better direct the design process, the A&E firm might have produced an improved design which would cost less in the first place. Regardless of the merit of value engineering, this practice has undermined the role of the A&E firm as a prime professional acting on the behalf of the owner to supervise the contractor. Now we're going to talk about professional construction managers. In recent years, a new breed of construction managers offers professional services from the inception to the completion of a construction project. These construction managers mostly come from the ranks of A&E firms or general contractors who may or may not retain dual roles in the service of the owners. In any case, the owner can rely on the service of a single prime professional to manage the entire process of a construction project. However, like the A&E firms of several decades ago, the construction managers are appreciated by some owners, but not by others. Before long, some owners find that the construction managers too may try to protect their own interest instead of that of the owners when the stakes are high. It should be obvious that all involved in the construction process that the party which is required to take higher risk demands larger rewards. If an owner wants to engage an A&E firm on the basis of low fees instead of the established qualifications, it often gets what it deserves. Or if the owner wants the general contractor to bear the cost of uncertainties in construction, such as foundation conditions, the contract price would be higher even if competitive bidding is used in reaching a contractual agreement. Without mutual respect and trust, the owner cannot expect construction managers to produce better results than other professionals. Hence, an owner must understand its own responsibility and the risk it wishes to assign to itself and to other participants in the process. Although many owners keep a permanent staff for the operation and maintenance of construction facilities, others may prefer to contract such tasks to professional managers. Understandably, it is common to find in-house staff for operation and maintenance in specialized industrial plants and infrastructure facilities, and the use of outside managers under the contracts for the operation and maintenance of rental properties such as apartments and office buildings. However, there are exceptions to these common practices. For example, maintenance of public roadways can be contracted to private firms. In any case, managers can provide a spectrum of operation and maintenance services for a specified time period in accordance to the terms of contractual agreements. Thus, the owners can be spared the provision of in-house expertise to operate and maintain facilities. As a logical extension of obtaining the best services throughout the project lifecycle of a constructed facility, some owners and developers are receptive to adding strategic planning at the beginning and facility maintenance as a follow-up to reduce space-related costs in their real estate holdings. Consequently, some architectural or engineering firms and construction management firms with compute-based expertise, together with interior design firms, are offering such front-end and follow-up services in addition to the more traditional services in design and construction. Facilities management is a discipline of planning, designing, constructing, and managing space in every type of structure, from office buildings to process plants. It involves developing corporate facilities policies, long-range forecasts, real estate, space inventories, projects through design, construction, and renovating, building operation and maintenance plans, and furniture and equipment inventories. A common denominator of all firms entering into these new services is that they all have strong computer capabilities and heavy computer investments. In addition to the use of computers for aiding design and monitoring construction, the service includes the compilation of a computer record of building plans that can be turned over at the end of construction to the facilities management group of the owner. The computer database of facilities information makes it possible for planners in the owner's organization to obtain overview information for long-range space forecasts, while the line managers can use as-built information such as lease tenant records, utility costs, etc. for day-to-day operations. So last but not least, let's talk about construction contractors. Now, builders who supervise the execution of construction projects are traditionally referred to as contractors, but sometimes they're more appropriately named constructors. The general contractor coordinates various tasks for a project, while the specialty contractors, such as mechanical or electrical contractors, perform the work in their own specialties. Material and equipment suppliers often act as installation contractors. They play a significant role in a construction project since the condition of delivery of materials and equipment affect the quality, cost, and timely completion of the project. It is essential to understand the operation of these contractors in order to deal with them effectively. The function of a general contractor is to coordinate all tasks in a construction project. Unless the owner performs this function or engages a professional construction manager to do so, a good general contractor who has worked with a team of superintendents, specialty contractors, or subcontractors together for a number of projects in the past can be most effective in inspiring loyalty and cooperation. The general contractor is also knowledgeable about the labor force employed in the construction, and the labor force may or may not be unionized depending on the size and location of the projects. In some projects, no member of the workforce belongs to a labor union. In other cases, both union and non-union craftsmen work together in what is called an open shop. Or all craftsmen must be affiliated with labor unions in a closed shop. Some labor unions provide hiring halls staffed with skilled journeymen who have gone through apprenticeship programs for the projects, as well as serving as collective bargaining units. And experienced general contractors will make good use of the benefits and avoid the pitfalls in dealing with organized labor. So the other kind of contractors is specialty contractors. Specialty contractors include mechanical, electrical, foundation, excavation, and demolition contractors, among others. They usually serve as subcontractors to the general contractor for project. In some cases, legal statutes may require an owner to deal with various specialty contractors directly. In the state of New York, for example, specialty contractors, such as mechanical and electrical contractors, are not subjected to the supervision of the general contractor of a construction project and must be given separate prime contracts on public works. With the exception of such special cases, though, an owner will hold the general contractor responsible for negotiating and fulfilling the contractual agreement with the subcontractors. And then there's the material and equipment suppliers. Major material suppliers include specialty contractors in structural steel fabrication and erection, sheet metal, ready-mix concrete delivery, reinforcing steel bar detailers, roofing, glazing, and so on. Major equipment suppliers for individual construction include manufacturers of generators, boilers, piping, and other equipment. Many suppliers handle on-site installation to ensure that the requirements and contractual specifications are met. As more and larger structural units are prefabricated off-site, distribution between specialty contractors and material suppliers becomes even less obvious.
Are you listening? Please click the following button to continue.
Hello everyone, and welcome to Chapter 30. The first couple of topics we're going to be covering are about financing. So a major construction project requires an enormous amount of capital that is often supplied by lenders who want to be assured that the project will offer a fair return on the investment. Direct costs associated with a major construction project may be broadly classified into two categories. First, the construction expenses paid to the general contractor for erecting the facility on site, and second, the expenses for land acquisition, legal fees, architect and engineering fees, construction management fees, interest on construction loans, and the opportunity cost of carrying empty space in the facility until it is fully occupied. The direct construction costs in the first category represent approximately 60 to 80% of the total cost in most construction projects. Since the costs of construction are ultimately borne by the owner, careful financial planning for the facility must be made prior to construction. And now we're going to talk about construction financing in more details. Construction loans to contractors are usually provided by banks or savings and loans associations for construction financing. Upon the completion of the facility, construction loans will be terminated and the post-construction facility financing will be arranged by the owner. Construction loans provided for different types of construction may vary. In the case of residential housing,
construction loans and long-term mortgages can be obtained from savings and loans associations or commercial banks. For institutional and commercial buildings, construction loans are usually obtained from commercial banks. Since the value of specialized constructible buildings as collateral for loans is limited, construction loans in this domain are rare, and construction financing can be done from the pool of general corporate funds. For infrastructure construction owned by the government, the property cannot be used as security for a private loan, but there are many possible ways to finance the construction, such as general appropriation from taxation or special bonds issued for the project. Traditionally, banks serve as a construction lender in a three-party agreement among the contractor, the owner, and the bank. The stipulated loan will be paid to the contractor on an agreed schedule upon the verification of completion of various portions of the project. Generally, a payment request together with a standard progress report will be submitted each month by the contractor to the owner, which in turn submits a draw request to the bank. Provided that the work to date has been performed satisfactorily, the disbursement is made on that basis during the construction period. Under such circumstances, the bank has been primarily concerned with the completion of the facility on time and within the budget. The economic life of the facility after its completion is not a concern because of the transfer of risk to the owner or an institutional lender. So that brings us to facility financing. Many private corporations maintain a pool of general funds resulting from retained earnings and long-term borrowing on the strength of corporate assets, which can be used for facility financing. Similarly, public agencies, the long-term funding may be obtained from commitment of general tax revenues from the federal, state, and or local governments. Both private corporations and public agencies may issue special bonds for the constructed facilities, which may obtain lower interest rates than other forms of borrowing. Short-term borrowing may also be used for bridging the gaps in long-term financing. Some corporate bonds are convertible to stocks under circumstances specified in the bond agreement. For public facilities, the assessment of user fees to repay the bond funds merits consideration for certain types of facilities, such as toll roads and sewage treatment plants. The use of mortgages is primarily confined to rental properties, such as apartments and office buildings. Because of the sudden surge of interest rates in the late 1970s, many financial institutions offer, in addition to the traditional fixed-rate long-term mortgage commitments, other arrangements, such as a combination of debt and a percentage of ownership in exchange for a long-term mortgage or the use of adjustable-rate mortgages. In some cases, a construction loan may be granted on an open-ended basis without a long-term financing commitment. For example, the plan might be used for the construction period with an option to extend it for a period of up to 3 years in order to give the owner more time to seek alternative long-term financing on the completed facility. The bank will be drawn into situations involving financial risk if it chooses to be a lender without long-term guarantees. For international projects, the currency used for financing agreements becomes important. If financial agreements are written in terms of local currencies, then fluctuations in the currency exchange rate can significantly affect the cost and ultimately profit of a project. In some cases, payments might also be made in particular commodities, such as petroleum, for the output from the facility itself. Again, these arrangements result in greater uncertainty in the financing scheme because the price of these commodities may vary. Now that we've talked about financing, it's time to go into legal and regulatory requirements. The owners of facilities naturally want legal protection for all the activities involved in the construction. It is equally obvious that they should seek competent legal advice. However, there are certain principles that should be recognized by owners in order to avoid unnecessary pitfalls. Activities in construction often involve risks, both physical and financial. An owner generally tries to shift the risks to other parties to the degree possible when entering into contractual agreements with them. However, such action is not without cost or risk. For example, a contractor who is assigned the risks may either ask for a higher contract price to compensate for the higher risks, or end up in non-performance or bankruptcy as an act of desperation. Such consequences can be avoided if the owner is reasonable in risk allocation. When risks are allocated to different parties, the owner must understand the implications and spell them out clearly. Sometimes there are statutory limitations on the allocation of liabilities among various groups, such as prohibition against the allocation of negligence in design to the contractor. An owner must realize his superior power in bargaining and hence the responsibilities associated with this power in making contractual agreements. It is important for the owner to use legal counselors as advisors to mitigate conflicts before they happen, rather than to wield conflicts as weapons against other parties. There are enough problems in design and construction due to uncertainty rather than bad intentions. The owner should recognize the more enlightened approaches for mitigating conflicts, such as using owner-controlled wrap-ups insurance, which will provide protection for all parties involved in the construction process for unforeseen risks, or using arbitration, mediation, and other extrajudicial solutions for disputes among the various parties. However, these compromise solutions are not without pitfalls and should be adopted only on the merit of individual cases. Now let's talk about government regulation. To protect public safety and welfare, legislatures and various government agencies periodically issue regulations which influence the construction process, the operation of construction facilities, and their ultimate disposal. For example, building codes promulgated by local authorities have provided guidelines for design and construction practices for a very long time. Since the 1970s, many federal regulations that are related directly or indirectly to construction have been established in the United States. Among them are safety standards for workers issued by the Occupational Health and Safety Administration, environmental standards on pollutants and toxic waste issued by the Environmental Protection Agency, and design and operation procedures for nuclear power plants issued by the Nuclear Regulatory Commission. Owners must be aware of the impacts of these regulations on the cost and durations of various types of construction projects, as well as possibilities of litigation due to various contentions. So now that we've talked about the legal and regulatory challenges we might face in the industry, it's time to talk a bit more specific about the changing environment of the construction industry. We always talk about the construction industry this, construction industry that. It's actually a conglomeration of very diverse fields and participants that have been loosely lumped together as one sector of the economy. The construction industry plays a central role in national welfare, including the development of residential housing, office buildings, industrial plants, and the restoration of the nation's infrastructure and other public facilities. And the importance of the construction industry lies in the function of its products, which provide the foundation of industrial production, and its impact on the national economy cannot be measured by the value of its output or the number of persons employed in its activities alone. To be more specific, though, construction refers to all types of activities usually associated with the erection and repair of immobile facilities. Contract construction consists of a large number of firms that perform construction work for others and is estimated to be approximately 85% of all construction activities. 85%. So the remaining 15% of construction is performed by owners of the facilities and is referred to as forced account construction. Owners who pay close attention to the peculiar characteristics of the construction industry and its changing operating environment will be able to take advantage of the favorable conditions and to avoid potential pitfalls, which there are many of. Several factors are particularly noteworthy because of their significant impacts on the quality cost, and time of construction. So one of those most obvious factors is the new technologies. In recent years, technological innovation in design, materials, and construction methods have resulted in significant changes in construction costs. Computer aids have improved capabilities for generating quality designs as well as reducing the time required to produce alternative designs. New materials not only have enhanced the quality of construction, but also have shortened the time for shop fabrication and field erection. Construction methods have gone through various stages of mechanization and automation, including the latest development of construction robotics. The common theme here is, time. Time is money, and also, less labor requirements. The most dramatic new technology applied to construction has been the internet and its private corporate intranet versions. The internet is widely used as a means to foster collaboration among professionals on a project, to communicate for bids and results, and to procure necessary goods and services. Real-time video from specific construction sites is widely used to illustrate construction progress to interested parties. The result has been more effective collaboration, communication, and procurement. The effects of many new technologies on construction costs have been mixed because of the high development costs for new technologies. However, it is unmistakable that design professionals and construction contractors who have not adapted to changing technologies have been forced out of the mainstream of design and construction activities. Ultimately, construction quality and cost can be improved with adoption of new technologies which are proved to be efficient from both the viewpoints of performance and economy. So you can't just dig your head into the sands, and pretend nothing's going on out there. You have to try new technologies. Doesn't matter if there are risks involved, because if you don't, you're going to get left out for sure. So now the second factor is labor productivity. The term productivity is generally defined as a ratio of production output volume to the input volume of resources. So output versus input. Since both output and input can be quantified in a number of ways, there is no single measure of productivity that is universally applicable, particularly in the construction industry, where the products are often unique and there is no standard for specifying the levels for aggregation of data. However, since labor constitutes a large number of the cost of construction, labor productivity in terms of output volume, which sometimes can be thought of as constant dollar value or functional units per person hour, is a useful measure. So constant dollar value per person hour or functional units per person hour. Labor productivity measured in this way does not necessarily indicate the efficiency of labor alone, but rather measures the combined effects of labor, equipment, and other factors contributing to the output. While aggregate construction industry productivity is important as a measure of national economy, owners are more concerned about the labor productivity of basic units of work produced by various crafts on site. Thus, an owner can compare the labor performance at different geographic locations under different working conditions and for different types and sizes of products. Different types of and sizes of projects. Construction costs usually run parallel to material prices and labor wages. Actually, over the years, labor productivity has increased in some traditional types of construction and thus provides a leveling or compensating effect when hourly rates for labor increase faster than other costs in construction. However, labor productivity has been stagnant or even declined in unconventional or large-scale projects. So speaking of
large scale, let's move on to our next factor, international competition. A final trend which deserves note is the increasing level of international competition in the construction industry. Owners are likely to find non-traditional firms bidding for construction work, particularly on large projects. When we speak of non-traditional, that usually means international. Separate bids from numerous European, North American, across the border, and Asian construction firms are not unusual. The winning bidder arranged overseas fabrication of the rig, kept overhead costs low, and proposed a novel assembly procedure by which construction equipment was mounted on complete sections of the platform in order to speed the completion of the entire structure. The result was lower costs than those estimated and bid by traditional firms. Of course, U.S. firms, including A&E firms, contractors, and construction managers, are also competing in foreign countries. Their success or failure in the international arena may also affect their capacities and vitality to provide services in the domestic market. So now let's talk about contractor finance projects. Increasingly, some owners look to contractors or joint ventures as a source to design, to build, and to finance a constructor's facility. For example, the utility company may seek a consortium consisting of the design and construct firm and a financial investment firm to assume a total liability during construction and thereby eliminate the risk of cost escalation to ratepayers, stockholders, and the management. On the other hand, a local sanitation district may seek such a consortium to provide private ownership for a proposed new sewage treatment plant. In the former case, the owner may take over the completed facility and service the debt on construction through long-term financing arrangements. In the latter case, the private owner may operate the completed facility and recover its investment through user fees. The activities of joint ventures among design, construction, and investment firms are sometimes referred to as financial engineering. This type of joint venture has become more important in the international construction market, while aggressive contractors often win contracts by offering a more attractive financing package rather than superior technology. With the deepening shadow of international debts in recent years, many developing countries are not in a position to undertake any new project without contractor-backed financing. Thus, the contractors or joint ventures in overseas projects are forced into very risky positions if they intend to stay in the competition. Now let's talk about lean construction. Lean manufacturing had a revolutionary effect on many industries, especially automotive assembly companies. Characteristics of this approach include improvement in quality and reduction of waste everywhere. Rather than increasing costs, reducing defects and waste proved to be improved quality and reduced costs. Who would have thought? Empowering workers to be responsible to satisfying customer needs. In construction, for example, craftsmen should make sure their work satisfied the design intent. The other one would be continuous improvement of processes involving the entire workforce. So lean construction is intended to spread these practices within the construction industry. Of course, well-managed construction projects already have many aspects of lean construction. For example, just-in-time delivery of materials is commonplace to avoid the waste of large inventory stockpiles. Green building projects attempt to reuse or recycle all construction wastes. But systematic attention to continuous improvement and zero accidents and defects is new. So now the last part we want to talk about this chapter, the last topic, is the role of project managers. Now, in the project lifecycle, the most influential factors affecting the outcome of the project often reside at the early stages. At this point, decisions should be based on competent economic evaluation with due consideration for adequate financing, the prevalent social and regulatory environment, and technological considerations. Architects and engineers might specialize in planning, construction field management, or in operation, but as project managers, they must have some familiarity with all such aspects in order to understand properly their role and be able to make competent decisions. Since the 1970s, many large-scale projects have run into serious problems of management, such as cost overruns and long schedule delays. Actually, the management of mega projects or super projects is not a practice peculiar to our time. We witnessed the construction of transcontinental railroads in the Civil War era and the construction of the Panama Canal at the turn of last century. Although the mega projects of this generation may appear in greater frequency and present a new set of challenge, the problems are organizational rather than technical. It is customary to think of engineering as part of a trilogy: pure science, applied science, and engineering. It needs emphasis that this trilogy is only one of a triad of trilogies into which engineering fits. This first is pure science, applied science, and engineering. The second is economic theory, finance, and engineering. And the third is social relations, industrial relations, and engineering. So three triads, each with three factors. Many engineering problems are as closely allied to social problems as they are to pure science. As engineers advance professionally, they often spend as much or more time on planning, management, and other economic or social problems as on the traditional engineering design and analysis problems which form the core of most educational programs. It is upon the ability of engineers to tackle all such problems that their performance will ultimately be judged. The greatest stumbling block to effective management in construction is the inertia and historic divisions among planners, designers, and constructors. While technical competence in design and innovation remains the foundation of engineering practice, the social, economic, and organizational factors that are pervasive in influencing the success and failure of construction projects must also be dealt with effectively by design, construction organization. Of course, engineers are not expected to know every detail of management techniques, but they must be knowledgeable enough to anticipate the problems of management so that they can work harmoniously with professionals in related fields to overcome the inertia and historic divisions. Paradoxically, engineers who are creative in engineering design are often innovative in planning and management, since most types of activities involve problem solving. In fact, they can reinforce each other if both are included in the education process, provided that creativity and innovation instead of routine practice are emphasized. A project manager who is well educated in the foundational principles of engineering design and management can usefully apply such principles once he or she has acquired basic understanding of a new application area. A project manager who has been trained by rote learning for a specific type of project may merely gain 1 year of experience repeated 20 times, even if he or she has been in the field for 20 years. A broadly educated project manager can reasonably hope to become a leader in the profession. A narrowly trained project manager is often relegated to the role of his or her first level let me just rephrase that again. A narrowly trained project manager is often relegated to the role of his or her first job level permanently. The owners have much at stake in selecting a competent project manager and in providing her or him with the authority to assume responsibility for various stages of the project, regardless of the type of contractual agreements for implementing the project. Of course, the project manager must also possess the leadership quality and the ability to handle effectively the intricate interpersonal relationships within an organization. The ultimate test of the education and experience of a project manager for construction lies in her or his ability to apply fundamental principles to solving problems in new and unfamiliar situations, which have become the hallmarks of the changing environment in the construction industry. So now let's dig a bit more into what exactly is project management. The management of construction projects require knowledge of modern management as well as an understanding of the design and construction process. Construction projects have a specific set of objectives and constraints, such as required time frame for completion. Whether relevant technology, institutional arrangements, or processes will differ, the management of such projects has much in common with the management of similar types of projects in other specialty or technology domains, such as aerospace, pharmaceutical, and energy developments. Generally, project management is distinguished from the general management of corporations by the mission-oriented nature of a project. A project organization will generally be terminated when the mission is accomplished. Project management is the art of directing and coordinating human and material resources throughout the life of a project by using modern management techniques to achieve predetermined objective of scope, cost, quality, and participation satisfaction. By contrast, the general management of business and industrial corporations assumes a broader outlook with greater continuity of operations. Nevertheless, there are sufficient similarities as well as differences between the two so that modern management techniques developed for general management may be adapted for project management. Working knowledge of general management and familiarity with the special knowledge domain related to the project are indispensable. Supporting disciplines such as computer science and decision science may also play an important role. In fact, modern management practices and various special knowledge domains have absorbed various techniques or tools which were once identified only with the supporting disciplines. For example, computer-based information systems and decision support systems are now commonplace tools for general management. Similarly, many operation research techniques such as linear programming and network analysis are now widely used in many knowledge or application domains. Specifically, project management in construction encompasses a set of objectives which may be accomplished by implementing a series of operations subject to resource constraints. There are potential conflicts between the stated objectives with regard to scope, cost, time, and quality, and the constraints imposed on human material and financial resources. These conflicts should be resolved at the onset of a project by making the necessary trade-offs or creating new alternatives. Subsequently, the functions of project management for construction generally include the following. The first, the specification of project objectives and plans, including delineation of scope, budgeting, scheduling, setting performance requirements, and selecting project participants. Second, maximization of efficient resource utilization through procurement of labor, materials, and equipment according to the prescribed schedule and plan. Third, implementation of various operations through proper coordination and control of planning, design, estimating, contracting, and construction in the entire process. The fourth,
development of effective communication and mechanisms for resolving conflicts among the various participants. The Project Management Institute focuses on 9 distinct areas requiring project manager knowledge and attention. First, project integration management to ensure that the various project elements are effectively coordinated. Second, project scope management to ensure that all the work required and only the required work is included. Third, project time management to provide an effective project cycle. Fourth, project cost management to identify needed resources and maintain budget control. Fifth, project quality management to ensure functional requirements are met. And sixth, project human resource management to development and effectively employ project personnel. Seventh, project communication management to ensure effective internal and external communications. Eighth, project risk management to analyze and mitigate potential risks. And last, the ninth, project procurement management to obtain necessary resources from external sources. These 9 areas form the basis of the Project Management Institute certification program for project managers in any industry. So with all that in mind, what are the trends in modern management today? In recent years, major developments in management reflect the acceptance to various degrees of the following elements. The first is the management process approach. The second, the management science and decision support approach. Third, the behavioral science approach for human resource development. And fourth, sustainable competitive advantage. These 4 approaches complement each other in the current practice and provide a useful groundwork for project management. The management process approach the project management approach emphasizes a systematic study of management by identifying management functions in an organization and then examining each in detail. There is general agreement regarding the functions of planning, organizing, and controlling. A major tenet is that by analyzing management along functional lines, a framework can be constructed into which all new management activities can be placed. Thus, the manager's job is regarded as coordinating a process of interrelated functions which are neither totally random nor rigidly predetermined, but are dynamic as the process evolves. Another tenet is that management principles can be derived from an intellectual analysis of management functions. By dividing the manager's job into functional components, principles based upon each function can be extracted. Hence, management functions can be organized into hierarchical structure designed to improve operational efficiency. The basic management functions are performed by all managers, regardless of enterprise, activity, or hierarchical levels. Finally, the development of a management philosophy results in helping the manager to establish relationships between human and material resources. The outcome of following an established philosophy of operation helps the manager win the support of the subordinates in achieving organizational objectives. The management science and decision support approach contributes to the development of a body of quantitative methods designed to aid managers in making complex decisions related to operations and production. In decision support systems, emphasis is placed on providing managers with relevant information. In management science, a great deal of attention is given to defining objectives and constraints, and to constructing mathematical analysis models and solving complex problems of inventory, materials, and production control, among others. A topic of major interest in management science is the maximization of profit. And in the absence of workable model for the operation of the entire system,
suboptimization of the operations of its components. The optimization of suboptimization is often achieved by the use of operations research techniques, such as linear programming, quadratic programming, graph theory, queuing theory, and Monte Carlo simulation. In addition to the increasing use of computers, accompanied by the development of sophisticated mathematical models and information systems, management science and decision support systems have played important roles by looking more carefully at problem inputs and relationships, and by promoting goal formulation, management of performance. Artificial intelligence has also begun to be applied to provide decision support systems for solving ill-structured problems in management. The behavioral science approach for human resource development is important because management entails getting things done through the action of people. An effective manager must understand the importance of human factors such as needs, drive, motivation, leadership, personality, behavior, and work groups. Within this context, some place more emphasis on the interpersonal behavior, which focuses on the individual and his or her motivations as a socio-psychological being. Others emphasize more group behavior in recognition of the organized enterprise as a social organism, subject to all the attitudes, habits, pressures, and conflicts of the cultural environment of people. The major contribution made by the behavioral scientists to the field of management include, first, the formulation of concepts and explanations about the individual and group behavior in the organization, and second, the empirical testing of these concepts methodically in many different experiments and field settings, and third, the establishment of actual managerial policies and decisions of operation based on the conceptual and methodological frameworks. Sustainable competitive advantage stems primarily from good management strategy. As Michael Porter of the Harvard Business School argues, strategy is creating fit among a company's activities. The success of strategy depends on doing many things well, not just a few, and integrating among them. If there is no fit among activities, there is no distinctive strategy and little sustainability. In this view, successful firms must improve and align the many processes underway to their strategic vision. Strategic positioning in this fashion requires first, creating a unique and valuable position, and second, making trade-offs compared to competitors, and third, creating a fit among a company's activities. Project managers should be aware of the strategic position of their own organization and the other organizations involved in the project. The project manager faces a difficult task of trying to align the goals and strategies of these various organizations to accomplish the project goals. For example, the owner of an industrial project may define a strategic goal as being first to market with new products. In this case, facilities development must be oriented to fast-track rapid construction. As another example, a contracting firm may see their strategic advantage in new technologies and emphasize profit opportunities from value engineering. So now we move on to strategic planning and project programming. The programming of capital projects is shaped by the strategic plan of an organization, which is influenced by market demands and resources constraints. The programming process associated with planning and feasibility studies sets the priorities and timing for initiating various projects to meet the overall objectives of the organizations. However, once this decision is made to initiate a project, market pressure may dictate early and timely completion of the facility. Among various types of construction, the influence of market pressure on the timing of initiating a facility is the most obvious in industrial construction. Demand for an industrial product may be short-lived, and if a company does not hit the market first, there may not be a demand for its product later. With intensive competition for national and international markets, the trend of industrial construction moved towards shorter project life cycles, particularly in technology-intensive industries. In order to gain time, some owners are willing to forego thorough planning and feasibility study so as to proceed on a project with inadequate definition of the project scope. Invariably, subsequent changes in project scope will increase construction costs. However, profits derived from an early facility operation can often justify the increase in construction costs. Generally, if the owner can derive reasonable profits from the operation of a completed facility, the project is considered a success anyway, even if construction costs far exceed the estimate based on an inadequate scope definition. In the end, that's all that matters. The attitude may be attributed in large part to the uncertainties inherent in construction projects. It's difficult to argue that profits might be even higher if construction costs could be reduced without increasing the project duration. However, for some projects, notably some nuclear power plants, when they are clearly unsuccessful and abandoned before completion, and their demise might be attributed, at least in part, to inadequate planning and poor feasibility studies. The owner or facility sponsor holds the key to influence the construction costs of a project, because any decision made at the beginning stage of a project lifecycle has far greater influence than those made at later stages. Moreover, the design and construction decision will influence the continuing operating costs and, in many cases, the revenues over the facility's lifetime. So, therefore, an owner should obtain the expertise of professionals to provide adequate planning and feasibility studies. Many owners do not maintain an in-house engineering and construction management capability, and they should consider the establishment of an ongoing relationship with an outside consultant in order to respond quickly to requests. Even among those owners who maintain engineering and construction divisions, many treat these divisions as reimbursable, independent organizations. Such an arrangement should not discourage their legitimate use, as false economies and reimbursable costs from such divisions can indeed be very costly to the overall organization. Finally, the initiation and execution of capital projects places demands on the resources of the owners and the professionals and contractors to be engaged by the owner. For very large projects, it may bid up the price of engineering services as well as the cost of materials and equipment and the contract prices of all types. Consequently, such factors should be taken into consideration in determining the timing of a project. So now, let's see an example about setting priorities for projects. A department store planned to expand its operations by acquiring 20 acres of land in the southeast of a metropolitan area, which consists of well-established suburbs for middle-income families. An architectural or engineering firm was engaged to design a shopping center on a 20-acre plot with the department store as its flagship, plus a large number of storefronts for tenants. 1 year later, the department store owner purchased 2,000 acres of farmland in the northwest outskirts of the same metropolitan area and designated 20 acres of this land for a shopping center. The E&E firm was again engaged to design a shopping center at this new location. The E&E firm was kept completely in the dark while the assemblage of the 2,000 acres of land in the northwest quietly took place. When the plans and specifications for the southeast shopping center were completed, the owner informed the E&E firm that it would not proceed with the construction of the southeast shopping center for the time being. Instead, the owner urged the E&E firm to produce a new set of similar plans and specifications for the northwest shopping center as soon as possible, even at the sacrifice of cost-saving measures. When the plans and specifications for the northwest shopping center were ready, the owner immediately authorized its construction. However, it took another 3 years before the southeast shopping center was finally built,
The reason behind the change of plan was that the owner discovered the availability of the farmland in the northwest, which could be developed into residential real estate properties for upper middle income families. The immediate construction of the Northwest Shopping Center would make the land development parcels more attractive to home buyers. Thus, the owner was able to recoup enough cash flow in the 3 years to construct the Southeast Shopping Center in addition to financing the construction of the Northeast Shopping Center, as well as the land development in this vicinity. While the owner did not want the construction costs of the Northwest Shopping Center to run wild, it apparently was satisfied with the cost estimates based on the detailed plans of the Southeast Shopping Center. Thus, the owner had the general idea of what the construction cost of the Northwest Shopping Center would be. He did not wish to wait for more defined cost estimates until the detailed plans for that center were ready. To the owner, the timeliness of completing the construction of the Northwest Shopping Center was far more important than reducing the construction costs and fulfilling its investment objectives. Another example, resource constraints for megaprojects. The major problem with megaprojects is the severe strain placed on this environment, particularly on the resources in the immediate area of a construction project. Mega or macro projects involve construction of very large facilities, such as the Alaska Pipeline constructed in the 1970s, or the Panama Canal constructed in the 19th centuries. Limitations in some or all basic elements required for the successful completion of a mega project include, first, engineering design professionals, of course, to provide sufficient manpower to complete the design within a reasonable time limit. Second, construction supervisors with capacity and experience to direct large projects. And the third is the number of construction workers with proper skills to do the work. And the fourth element is the market to supply materials in sufficient quantities and of required quality on time. Our fifth and the last one is the ability of the local infrastructure to support the large number of workers over an extended period of time, including housing, transportation, and other services. To compound the problem, mega projects are often constructed in remote environments away from major population centers and subject to severe climate conditions. Must be evaluated carefully.